wasn't me. Okay, we're going to be talking to you about fireworks and how calculus pertains to it. I'm Michael Mays, and
I'm Yifei.
let's get started here. We've got a little exposition here on the history of fireworks.
I will talk about the history about fireworks. The earliest document of fireworks date back to the 7th century of China, and Chinese people were invented fireworks, and the fireworks were used to accompany many festivities. It's a part of culture of in China, and it's eventually separate to other region and other country like Japan and Singapore. And important events and festivities such as Spring Festival, Mid-Autumn Festival are time when fireworks are guaranteed sites. And China is the largest manufacturer and explorer of fireworks in the world. Fireworks can produce various shapes such as simple rotated circle and stars and 3D globe.
Moving on. Okay, so where's the math come in for fireworks? A little more of the exposition. There's a whole lot of different fireworks. I don't know if you guys have ever messed with the fireworks go up in the air, the aerial fireworks. There's a lot of laws that prevent civilians from using those because we're stupid and we catch things on fire when we're allowed to mess with them. So I think a lot of you will experience ground fireworks, like the spinning wheels, the things that just light up, that shoot sparks in the air and stuff like that. But mainly where the calculus and physics comes in is, of course, the aerial fireworks, and that's mostly projectile motion. You're like kicking a soccer ball, shooting a cannon, shooting fireworks in the air. It's pretty much the same thing. You know, you have your X, Y, Z. You have initial velocity. You have your initial position. You have downward acceleration due to gravity, and if you really want to go into detail, you also have horizontal acceleration due to wind resistance and things like that. Oops. Oh, this kind of is a big your bottle rockets. Pretty simple aerial fireworks that people don't use. There's two different kinds of aerial fireworks. There's skyrockets and there's mortars. And skyrockets are like your bottle rockets that everyone lights up and shoots off. But professionals don't really use this. It's kind of unpredictable. They use an internal motor with you light a fuse and it shoots up in the air. They're not really predictable because they have variable acceleration and stuff like that. So professionals use mortars. You know, you have your mortar, you shoot it up. It has a initial force, and after that you're done. You can just calculate using your projectile motion. When you're talking about like safety and stuff, professionals, you know, they have to have safety margins and stuff like that. It's better to have predictable fireworks than unpredictable fireworks. So you won't really see professionals use these ever. Moving on. I think it's also what I just said. You have anything to add? No. It's pretty much this is what a professional setup would look like on a barge. Except usually by the time they're done, the entire thing is covered with fireworks. All the wires you see and stuff like that are them, the timing and programming that they do. They all set it all up with a computer because it's pretty tough to do it by hand. And you don't really see it nowadays with people running down barges lighting all the fireworks at times. So it's pretty much all done by computer because it's a lot easier to do math on a computer than it is by hand. And they can program it so that this firework goes off at this time, this firework goes off at this time, shoot at certain angles so that they go off at this place at this time, this place at this time. All this projectile motion because you have different times, different positions, usually the same initial velocity depending on the mortar, but it's all math. And there's the math. This is the real basics of it. It doesn't take into account your wind acceleration because we usually don't do that in class, and it's kind of tough because it changes depending on how fast the wind is going. But you basically have your initial x position plus your initial x velocity times time, and same for y and z, except z also has gravity. Take it in negative 4.9 or negative 32, depending on whether you're doing feet or meters. That's it for now.
In the final exam package, there is a question like this.
There is?
Yeah.
Ah! Fireworks.
Is it?
Yeah,
Where's
I know.
David?
Fireworks
Yeah.
in the
Does it remind you?
It was like 38 or something.
Yeah.
Put it on the phone.
I show you 38 is curvature.
So you know, why is all this important? You know, I kind of talked about it already. So, you know, safety. You know, pyrotechnicians, which professionals that do with fireworks, they have certain safety areas. You know, like imagine a fireworks show has like a big box, and fireworks have to stay within that box because certain wind, whatever variations. You don't want fragments of fireworks falling into the audience because then you just lost a bunch of credibility and a lot of money. But then there's also the show itself. You're putting on a show, so you want it to look good, which means a bunch of random fireworks go off at different times. I mean, it's just still pretty, but it's not a show. You want it to be ooh ah, not like ooh that's pretty. But certain timing things, like if you have fireworks shows that go along with music, you want fireworks to go with the beat and stuff like that. So you have to time that. You have to have where the position's going to be at this time. So when it goes off, it's still going with the music, but you're like little patterns and like waveforms and stuff like that, depending on how professional your fireworks show is and stuff like that. But explosions, again, fragments going into the crowd. Each fragment also has its own projectile motion that might want to be calculated for. It depends on the fireworks. Sometimes the fragments go off sideways, sometimes they go in all directions, sometimes just poof, go down. But all the fireworks fragments also have to fall into the safety zone. You have to do projectile motion to find out if it explodes with this much force, where the fragment's going to go. Where can this firework explode so that the fragments don't go into the audience? Things like that. How it all falls together.
All of the calculation done are for a single purpose, to enjoyment of the crowd.
It's pretty much what I said. Yeah, it's a show. It's pretty much, if you think about it. I mean, pyrotechnicians, they do a lot of with computers. I don't know how much of the math and physics they know about it, but when it comes down to it, a fireworks show a lot of times is like a math show with pretty lights. You want the fireworks to go off at a certain time, certain place, and that all takes math or a computer, depending on which standpoint you look at. But the computer uses math, so when it comes down to it, you need math to make a good fireworks show. So,
have you actually been to a place where there was a firework synchronized with music?
I was gonna get to it. We had a video at the end that showed like a really good example of fireworks going off the music. But when I checked it this morning, the video had been deleted online. Like I checked it online, this item no longer exists.
There's one in
San
Disney World.
Francisco that
Yeah,
they had
Disney World.
barges, like loads of barges, and they were all set to go off. And for a little bit, they were timed right. I think it was either last New Year's or last 4th of July. But then at a certain point, it shows where it breaks down, and it's just all the barges start going at once. It's really intense.
It's the one we had was like it was like an architecture thing. Like it was some big architecture thing that they had made. I forget where it was exactly. It was somewhere in the U.S. I think it was California, but it was like a light show plus a fireworks show, and the fireworks were going off with the music, and the light show was just like doing crazy stuff on the building, and it was really interesting.
How about in China? Have you actually experienced that in China with the music?
Yeah, with music, no. Like we have the festival show in Spring Festival, and like the big festival, they play the show, and on the TV you see the Beijing Olympic game. Like
But
that.
no music.
I think they have music,
They
but
have music?
I'm not actually experienced.
I think it's more of a recent thing. Like in Disney World, I think they do it sometimes.
At Magic Kingdom now, remember
Yeah.
they have the following the electrical
Celebrate the
parade.
magic.
They have
Yeah,
At
they
9
usually
o'clock
have
at night.
big fireworks shows. I saw one really recently. It was really awesome. They like combine fireworks with light shows. Like they have like lights and stuff. They do all kinds of crazy things with lights, but at the same time they're shooting off fireworks to like go along with the light show. And that also goes to the timing, because you have lights doing one thing and fireworks doing another thing. You want them to synchronize. You don't want them to look completely random. So even if there's no music, you still have to synchronize the fireworks with the lights so that it looks really good. And if it doesn't, then you just have random fireworks going off during a light show. It's, like I said, it's still pretty, but it's not as much of a show, and that's the point of it. Like if you want to be a professional, you have to put on a show. Like you want to, oh, these guys are doing a fireworks show. This is awesome. One of those kinds of things, like grand finale. Well, we have the references here, but we also have a really cool math problem if we have time. That's it kind of like goes into the calculus of it. Basically, here's the math problem. You know, firework explodes at a height of 100 meters above the level of ground. This doesn't go in the projectile motion of the actual firework, but the fragments after the explosion. It breaks into a large number of very small fragments which move in every direction, all of them the same initial velocity of 20 meters per second. Assume that the fragments move without air resistance and uniform gravitational field of 9.8 meters per second squared. And find the volume in meters cubed of the region through which the fragments move before reaching the ground. So, if you can imagine it, the firework goes 100 meters in the air and explodes, fragments going in all directions. So it explodes in the form of a sphere, except gravity is acting on every fragment. So what it ends up forming is a parabola. There's half the parabola right there, a 3D parabola. So what we do is we can cut it in half and look at half of the parabola so that we only have z and x. And then we can rotate that around the y-axis to find the volume. So what we do is we find the maximum horizontal and vertical distances. You know, it explodes with an initial 20 meters per second initial velocity of 20 meters per second. So z max is just going to be 20 minus 9.8 because that's when it reaches its max, the t. So you take that, your z max ends up being 100 because you start out at 100 feet, plus 20 times t minus 4.9 t squared. That's your position function because its initial velocity is just going to be 20t minus 9.8. Once you integrate that, you get 20t minus 4.9 t squared, and then you add that to your position function of 100. Once you do that, you need to find your horizontal. Those of you who know, well, we've all done projectile motion, but we all know that if you launch something, its farthest horizontal distance is going to be when you launch it at 45 degrees, right? So what we do is we find the maximum horizontal distance of the fragments that shoot out at 45 degrees. So that's going to be pi over 4. So down there you take the position is 100 plus, you have to find out when it hits the ground first. So it hits the ground at 0 feet. So we need to solve for t with 100 plus 20 sine of pi over 4t minus 4.9 t squared. What that ends up being is 87.48 meters for its maximum horizontal distance. Now that we've found our horizontal and vertical maximum distances, we can just solve for the paraboloid. Since the parabola is going to be negative ax squared plus b, since it's down, we know our b is 120.41 because that's what we solved for our maximum z. So now we just need to solve for x, and x ends up being that. That in the square root. Square root of 120.41 minus z over 0.01567. Rotate that around the z-axis, which gives us, you know, it's pretty much a disk from 0 to z max. So the integral from 0 to z max of pi r squared, and that gives us our answer of the volume of the paraboloid formed by the fragments. And I just thought it was a really, really cool math problem. It kind of like goes into like, they don't solve this as pyrotechnicians. I mean, they need to know where the fragments are going to fall, but it's just a really cool example of how we can use math for fireworks like that.